Hello everyone, good morning. Welcome you back in the topic force and pressure. Yesterday, in a very short time, we have completed the force. So let us have a revision sort of thing for the force. What is force? Push or a pull on any object called as a force. What force need? Direction as well as magnitude to explain the force properly. So we need direction as well as magnitude. What do you mean by magnitude? The strength or the maybe quantity of the force is called as a magnitude. The value we can say is nothing but a magnitude. If elephant applies a force, it applies with a large magnitude compared to a dog. So magnitude, quantity of the force. The force, if it is in the same direction, gets added, and if it is in the opposite direction, it gets subtracted. Clear? There are some types of forces like maybe contact force or non-contact force. Contact force, maybe muscular force, frictional force are called as a contact forces. And non-contact force, magnetic force, gravitational force or electrostatic force is nothing but non-contact force. Gravitation, you can give easy example. Magnetic force also you have many examples. Electrostatic force, if you rub a comb on your hair, it attracts pieces of paper. Even the thunders are the electrostatic force, as we have seen yesterday. Effect of forces, that means what force can do. Force can change the motion of the object, maybe from rest to the motion or from moving to the rest, both. That means it can set any object in the motion or it can stop any object which is moving. Changes the direction. It can even change the moving object's direction, and it might change the shape of the object, like a rubber ball or like a clay. When you apply the force, it changes its shape. So this is the part of force we have seen in the last session. So today's session we are going to work on a very interesting concept, that is pressure. Now what is pressure and how the pressure and force are related? Let's understand. We have heard about this pressure word, maybe pressure of examination, right? Maybe don't apply any sort of a pressure. We have heard about this word pressure, atmospheric pressure. In a geography, you must have heard about atmospheric pressure. So, what exactly the pressure in terms of quantity, in terms of physics, we're going to understand in this topic. But before that, I would like to just give you a simple example. I have a very simple hammer in my hand, two wooden blocks, and two nails. I'm going to apply equal amount of force on both the nails in example number A and as well as example number B. Equal amount of force has been applied to both. What do you say? Which nail gets nailed inside the wooden block? A or B? It's very clear. B gets nailed inside the wooden block, right? This is not going to get nailed inside the wooden block. Why so? Even then, we apply the equal amount of force in both the places, both the cases, the effect is not same. Why the effect is not same? The simple reason is, here I have head towards the wooden block and here I have pointed end towards the wooden block. As it is pointed, the force impact will be more. Impact, I'm not saying force magnitude is more. Force is same, but the effect will be more. And as it is not pointed, it's not that sharp, the impact will be less. Now, don't you think this impact of force is not depend on the force, but it depend on the area on which the force is applied, right? Now this is the reason we need to have here a different quantity than the force, and that quantity is called as a pressure. Now in the B place, the place B, the pressure is more. What is pressure? The pressure is nothing but the force applied on the area. So in this particular part of the topic, we are going to work on this. We are going to understand the pressure properly. So what is the pressure? Pressure is force upon area. Means what? On a particular area over here, how much force is applied? That is called as a pressure. Right? So force upon area means if area is more, the pressure, that means this quantity, will be less. For an example, let's see. Now let's consider hammer is applying some pressure as 10 magnitude, and here the area is 5, and here the area is 1. Hammer is applying the same force. I'll calculate the pressure. Here the area is more. Let us see, pressure is equals to 10 upon 5, which is 2 in quantity. Whereas in this case, if I take pressure is force upon area 10 upon 1, which is 10 in quantity. So you can see the force, however the same it is applied, still due to less area, you can check the area is less, the quantity has increased, the pressure quantity is increased. So if area is more, the pressure will be less, and if area is less, the pressure will be more. This is the very simple idea I am giving you. Okay, so if area is more, the pressure is less, and if area is less, the pressure is more. We call this as inversely proportional. Okay, the pressure is inversely proportional to the area. Inversely matlab exactly opposite it works. Pressure, if you want more, you need area to be reduced. Let us check some examples. Let us see some examples. Isn't it, we have checked the pressure is equals to force upon area. If I take an example of sharp knife, right? This is the sharp knife. Isn't it, sharp knife cuts the thing properly than that of the blunt knife? What is the reason? The reason is this area is very, very less, right? The area of contact of the force, you can say, the area is very, very less. Less the area, more the pressure will be more, isn't it? What if I ask you to carry a 10 kg load, 10 kg load, now this is a 10 kg of bag with a very thin wire, and same way the 10 kg load with a wide strap, ऐसे wide strip से अगर मैंने उठाने के लिए बोला. So what do you think? I told you to carry this and this both. Where you will have more impact, where you might get hurted. So don't you think this will be very difficult to carry it, and rather this will be very easy to carry. Now what is happening here? The force is getting divided. As the area is more, check karo, as area is more, the force gets divided and the pressure will be less. Hope you understand. As area is more, देखो area is more होगा तो pressure क्या होगा? Less, because pressure is inversely proportional to the area, right? Here the area is more. Here in this first case, area is very less area, thin wire, very less area. So pressure will be more, right? As pressure is inversely proportional to the area. Or you can say force gets divided in this case, and it is not getting divided in this case, right? So if you take a very thin wire, the rope, even a simple thread like structure here for 10 kg, rather I would say you can't even lift the bag. You cannot even lift that particular bag. It might get cut as well. Your hand might get cut if you take a thread, isn't it? Whereas a strap of this particular, bag will help you to easily carry it. This is the reason in your school bag, for your school bag, you don't have just a rope there. For your school bag, you have a wide strap. Have you observed it? In your school bag, this is maybe your school bag, chain, है ना, ऐसे कुछ तो होता है ना. This is how your school bag looks like. I hope so. Okay, it has got a kind of a holder here, and we have a wide, I say, straps होते हैं इसके, wide straps होते हैं, right? These are the wide strap your school bag has got. Why it has got a wide strap? So that you can easily carry that load. Okay, because this area is more, the impact, the pressure applied by the school bag will be less. The area is more, the wide strap has got more area, and as it has got more area, the force gets divided in the area, and accordingly the pressure will be less, because pressure is inversely proportional to the area. Here area is more, the pressure will be less, right? You must have observed pointed pins of the stapler. If you check the stapler pins, it's not called as stapler pins, it's called as a staples. But for your understanding, I'm considering it as a stapler pins. So those staples, those stapler pins has got a very pointed tip. If you observe it, you just observe once, you take it and observe it, it has got a very pointed tip. So this is your stapler staple, ऐसे होता है if you closely observe it. Okay, and that's the reason you can check, you can understand such a thick paper paper bundle, the staple can easily stapler, the stapler can easily staple, right? You once you try with the pin, with your hand to put it inside the paper, you will understand it is really very hard to penetrate through those bundle. But staples with such a small instrument can do that. The reason is pointed tip, sharp pointed tip. Due to this, what happens is the pressure will be more. Why it is more this time? Because area is less. So area is less, the pressure will be of course more. As it is more, it might easily put inside the bundle, it penetrate through the bundle. The same way legs of camel. I don't know whether you have seen the camel or no. Legs of camel are of this category. ऐसे होता है. And it is very soft. So this width of this particular legs of camel makes him to apply less pressure. See, of course, the weight of camel is quite high, quite large. It is heavy, of course. But weight means the force, right? He is applying some force on the ground. But these wide legs, wide and soft legs, will divide that weight properly. That's the reason camels can easily walk on the sand, whereas you and I will take really effort, hard effort to walk on the sand, right? Even in the snow, you need wide shoes or sneeze to walk on the snow, right? You must have observed that. That is due to more the area, less the pressure, right? Is this clear? So what we understood here in this particular slide is pressure is inversely proportional to the area. More the pressure, more the area, less the pressure, and less the area, more the pressure. There are so many examples that what significance you can say of this particular pressure is compared to force. So many examples we have, and few examples I have taken, right? Next one. Next is a very interesting concept called as a fluid pressure. Now first of all, let's understand what do you mean by fluids. Fluids means something that what it can flow, what can flow. So what is fluid? Liquid and gases are called as a fluid because they can flow. Fine. What is fluid pressure? Fluid pressure is a very interesting pressure. Very interesting. Fluid exert the pressure in all the directions. That means if you take a water in the glass, it exert pressure in each direction. In each direction. Try to understand. I'll give you a simple example. I have a two glass. In one glass there is a water. and in other glass there is nothing. Okay? I take a plastic ball of maybe some kind of a weight, and I put it in this particular glass, and I take a same plastic ball and I put it in this particular glass. Now what do you think? Isn't it this ball, the first A ball, will fall down and be there, whereas in the second one the ball will be just floating on the water surface. Now why do you think it is floating on the water surface? I know you will say density and all. But one thing, do you understand? Don't you think to keep the ball here, water need to apply some force from down there in this direction, then only it is holding it up? As like you hold it on your palm. When you hold something on your palm, right, ऐसे palm पे आप लोग जब कुछ hold करते हो, like a ball or like a heavy load, so isn't it we apply force in this direction? Same way, the water is holding this ball, that means it is applying some force in this direction. That's what I say. The liquid is applying pressure in upward direction, but not only upward direction, but in all the direction. That means it is applying the pressure on the walls of this container as well. Now how that we will understand. What if I feel the water in a balloon? Water if I feel in the balloon, this is a balloon, imagine. Don't you think it swells like a spherical shape, swell like a sphere? Right? So what does this proves? This proves that the water is applying the equal amount of pressure in the all the directions. That's the reason it gives you a spherical shape. Not only that, even soap bubbles. Soap bubbles, these are soap bubbles. Even soap bubbles are exactly spherical shape because there is a air inside it, and air exert exactly equal pressure in all the direction. That's the reason it gives you exactly spherical shape. I hope you must have observed soap bubbles. Right? Now this is what we call as a fluid pressure. This is what we call as a fluid pressure. I hope you are clear with the fluid pressure and understood the concept of fluid pressure. Right? There are so many examples that I can give you about fluid pressure. So many examples, so many different examples I can give you. Okay, a simple example I'll give you. This you can search it, you need to search it. I know that ocean, sea, is very deep. Okay, do you know that? Can you go towards to the end of the sea, at the last point of the sea? Maybe it is few kilometers, 2 to 3 kilometers. This the sea can be deep. Can we go? You tell me. I'll provide you all the oxygen cylinders and everything. Can we go down here? Okay? Can we go? Okay, let me tell you, you cannot go. If I take a simple watermelon and if I allow it that watermelon to go inside the sea at the bottom, before that itself, this watermelon gets burst. This watermelon gets burst. Try to understand. Why it bursts? The reason why it bursts is the water applies pressure on this. As we go down, as the depth of the ocean, depth of the water increases, the pressure also increases on any object. The pressure increases. And that's the reason this particular watermelon burst out. Now, one common question everyone might have faced or might have got it. What is that? Then how the animals can survive under there? How animals can be there? Okay, तो उसका reason I'll give you in short time. Don't worry. उसका भी reason मैं आपको बता रहा हूँ. Don't take tension. But at least you got it कि fluid pressure क्या होता है? It's a very large pressure. You must have even observed, even in the swimming tank. Swimming tank may be this much of height. This much of height. Even in the swimming tank, your ear might get a kind of a pain, a kind of a severe pain you get, and suddenly you come out of your swimming tank. If you have a practice, continuous practice, then you may not get that. But if you don't have practice of being in the swimming tank for longer time, your ears might get, a kind of a severe pain. That is due to that ear gets a continuous pressed, they get pressed due to the atmospheric pressure. And the when inside that particular ear, the blood vessels, you can say, they get, pressed, and blood won't flow through it, and that's the reason your ear gets, kind of a severe pain, and you suddenly come out of the water. After some time you feel better, right? Because airflow becomes proper, right? This is the pressure. This is what I talk about, fluid pressure. Isn't that interesting? Let's see some more example and some better understanding about fluid pressure, which might give you the idea about atmospheric pressure as well. Let us see that. Imagine there is a water bottle and water is filled till here. Till here the water is filled. And I have holes in the plastic bottle at point D, at point C, at point B, and at point A. Right? These are the holes in the bottle. And what I observed is, from the point A, the pressure is more. From the point B, its pressure is less than the A. From the point C, the pressure of the water coming out is less than the B. And from the D, it is less than all that. It is lowest. Now, what do you observe here? What do you understand here? The pressure that water applies on the wall, due to that only this water is coming out, isn't it? Through that particular hole. Because it is applying a pressure, so it comes out. But that pressure is depend on the height of the water above that particular point. Now, height of water above A point is largest. That's the reason the pressure is large. Okay, so you can understand, before this particular point, whatever the water is, the complete weight of that water will be the pressure at that particular point. Hope you understand. So if the depth is more, the pressure will be more. This is what we have seen in this ocean as well. The depth is more, the pressure will be more. Right? As the depth reduces, the pressure also gets reduces. We can see this with another example. Imagine I have a simple beaker, which is a glass vessel, which is open from both the ends. And if I put a kind of a balloon to its end, and if I feel some water in it, okay, if I feel the water in it, isn't it balloon gets some kind of inclination? Imagine if I increase the water, I added the water more. What will happen? Isn't it the balloon also gets inflated more than the previous one? So I hope you understand, the depth increases, the pressure also increases. The pressure, fluid pressure, I say, it increases. Fluid means what? Liquid as well as gases. Okay? Both are same. Now if both are same, the gas as well as liquid, both are same, then what will happen at the bottom of the sea? This is the sea, ocean you can say. What is happening at the bottom of this ocean? Don't you think we have a large pressure at the bottom of the ocean? Large pressure at the bottom of the ocean, right? Similarly, we also live in the similar atmosphere, but it is not of water, but it is of air. Isn't it? We have the ocean of air above us. Ocean of air. We have belts of heavy atmosphere above us. Heavy atmosphere above us. Right? And all that applies a pressure on you. All that applies a pressure on you. Right? I hope you understand. That is called as a atmospheric pressure. The whole atmosphere is applying a pressure on you. The air present, the complete weight of that air present is applying a pressure on you. Of course, we don't feel it. We don't feel it. There is a reason behind it. I'll tell you that reason in the short time, as well as why animals can survive inside this ocean. That also I'll be telling you, don't worry. But I hope you understand what is atmospheric pressure. Okay, that fluid applies a kind of a heavy pressure. Okay, and that is called as a atmospheric pressure. Let us take example. Let us feel that. Okay, where is the atmospheric pressure? Let us see the existence of atmospheric pressure. ठीक है? A rubber sucker. It's a kind of a rubber circular plate, and maybe to the hook this rubber suckers are available to the plane surface or maybe a glass surface. If you put this particular rubber sucker and remove the air from it, it sticks there. It sticks. ठीक है? Why it sticks according to you? What happens is, when the air goes from here, basically there is no air inside it, or maybe very rare air inside it, and atmosphere applies a pressure on this wall continuously. Atmosphere is applying a pressure. I hope you understand. Atmosphere is applying a pressure, and I'll tell you, with even a large force you cannot pull this out. You can't do that. Okay, the reason is atmosphere applies a pressure on these walls. Right, is this clear? So till the time there is no air inside it, no air goes inside this particular area, the rubber sucker continues to stay there for maybe even a longer time. For the years it will be there, because the atmosphere is applying a pressure. As soon as the air goes inside, this you might feel that it falls down. It will become very easy to remove it. It will be very easy to remove it. That's the rubber sucker. You can see the existence of the atmospheric pressure. Right? So why don't we feel the pressure? That heavy pressure, that what it is applied, why don't we feel the pressure? Now let us see why we don't feel that pressure. Why we don't feel that pressure? Because due to a continuous we are there in the particular atmosphere, our body has adopted that pressure, and inside our body we have also equal amount of pressure as the atmosphere has got. That means we apply the equal pressure to the atmosphere. So what will happen? Dekho, we apply the pressure on in this direction, and atmosphere applies the pressure on this direction. What will happen? This will become zero. Right? It nullifies the effect of the atmospheric pressure, because inside our body we have equal amount of atmospheric pressure. Right? Then how will you understand? How will you understand? You must have observed, or you must have heard about this, that mountaineers, when they climb to the higher height, or they climb to the distance on the mountain, blood comes out through their nose or maybe through their ears. Have you heard about this? If you haven't heard, please search about it. When the mountaineers climb on the height, what happens is blood comes out. Now why blood comes out? When we go to the height, देखो, the atmospheric pressure, I believe, imagine, here I'll go for it. This is the height when we are here on the ground, and this is the height when the mountaineers or climbers are. So don't you think this height is more than this height? This height is more than this height. Am I correct? So the mountaineers get less pressure from the atmosphere. So when they get less pressure from the atmosphere, and their body has got large pressure, so body moves, or inside the whatever we have, blood we have inside the body, which has got equal amount of atmospheric pressure, so that goes towards the लो प्रेशर. दैट मीन्स चेक करो, ये फोर्स ज़्यादा है, ये फोर्स ज़्यादा है, तो क्या होगा, ये ऑब्जेक्ट जो होगा, इमेजिन ये ऑब्जेक्ट है, दोनों इक्वल प्रेशर अप्लाई करें तो इट वोंट मूव. But if I apply from this direction large pressure, so body will move towards this side. Isn't it? The same thing happens. Atmosphere apply less pressure and body applies more pressure. So what will happen? What is inside the body? It comes out. Right? And that's the reason mountaineers face these kind of issues when they climb up on the mountain, that the atmosphere is less. As the atmosphere is less, the blood from their body will start coming out. Then how do they survive? The simple way is that they take a gap between their trach, between their trach. They take a gap. So when they climb up here, they will take a gap of 1 day, so that their body will be adopted to that particular atmosphere. Then they climb for some distance, and then again they take a gap, and in this manner they properly could climb up. Clear? Got the point? Did you understand? So this is what is nothing but the topic is all about. We have seen the pressure. What is the pressure? So let us take, pressure is nothing but force per unit area. Force per unit area. Less the area, more the pressure, and more the area, less the pressure. We have seen some examples, and then the important concept we have checked, the fluid pressure. Okay, and then we saw the sea, ocean. Under the ocean, if you take a watermelon, it might get burst due to the pressure of that particular, all the water above it. Then why can't these particular animals get affected due to that particular pressure? I think you must have got the reason. Like us, how we live in the ocean of air. Similarly, these animals live ocean of the water. Same thing it is. Same thing, let me tell you. So these animals live in the ocean of water, also adopted to that particular pressure, and inside their body they have similar pressure as outside. They have developed the pressure inside their body, and that is the reason the effect gets nullified, because from inside they apply the equal amount of pressure towards the outside, so effect gets nullified. And the same thing we as well, right? The pressure depend on the height of the fluid. The fluid pressure depend on the height of the fluid. If height or depth, you can say, depth is more, the pressure applied by the fluid also will be more, and that will be equal to the weight above that particular point. So that means at point A, how much pressure is there, so it will be weight of this particular object. So when I say that how much pressure is applied on you, your body, it is nothing but weight of the complete atmosphere around the earth. You can understand, it's such a heavy weight, and we don't feel that because we from our internal body also has got a same pressure against it, right? So we have seen the existence of atmospheric pressure, and that's it. Done the topic, right? I hope you enjoyed the topic. Tomorrow we will have the discussion of all the answers from the textbook. Till then, you can also try to answer the questions given in the exercise. Okay, try to find out the answers so that tomorrow we can verify. Thank you so much. Bye bye. See you tomorrow.